Now, let us try to understand the difference between conventional grid and the smart grid. So, the differences can be seen in terms of various characteristics. We will discuss them one by one. So, first is the architecture. So, in case of conventional power system network, the architecture is hierarchical and vertical. That means the generator will generate power and will pump power to the transmission network. Then transmission network will supply power to the distribution network. And finally, the distribution network will provide power to the loads. So this kind of structure is hierarchical. Now in case of smart grid, the structure will be unbundled with lot of distributed energy resources. That means that the generator will no longer be responsible for the generation of the electricity, while in case of a smart grid, the transmission as well as distribution as well as loads will have some contribution towards the energy generation. So in that case, the role of entities will be unbundled and the structure will also be distributed because the resources, say the generating resources, are now distributed across the power system network. Now, next is the consumer participation. The conventional power system has non-participative and uninformed customer. The customer is informed only about the bill. There is no role of customer towards the interaction in the power system, distribution or the other activity. While in case of the smart grid, the customer is no longer a customer, he is a prosumer. So he will be having informed and participative role because the consumer has to keep on getting the real-time prices as well as the loading conditions so that he can participate in the demand response and other activities in the power system network. Now, the third characteristic is the generation and storage options. So, in case of conventional power system network, the central generator has the dominance and there is no energy storage framework available in case of conventional power system network. While in case of smart grid, the role of distributed energy resources will be more and those DERs will be more of plug and play kind of feature. Since we have lot of intermittencies in case of distributed energy resources, that means that energy storage also needs to be integrated to adjust the supply balance equation when there is an intermittency in the distributed energy resources. The next characteristic is power quality. In the case of conventional power system network, the power quality is poor and there is a more focus on outage. So if there is a abnormal condition, the first thing which is done by the distribution companies is to switch off the network without any alternate path provided to the consumer to restore the electricity. So that's why the conventional power system network is very poor in the power quality. While in case of a smart grid, power quality is a priority. That's why reconfiguration and restoration is taken care by the distribution companies at fast pace so that the consumer is least affected. Now, next characteristic is new product and services. So, in case of conventional power system network, the new products are very limited. Consumers are not given the choices to choose a particular type of rates of electricity or particular type of option to have better price of the electricity. So that's why the consumer focus is very poor in case of conventional power system network because tariffs are regulated. That means the tariffs are designed by the regulatory commission, and consumer has very less option to switch over from one type of tariff to other type of tariffs. While in case of smart grid, there will be better market and services for consumer. Even if the consumer is not satisfied with his energy service provider, he has the option to switch over to new service provider. So in this case, the distribution system will be divided into two parts. One will be the wiring of the distribution system, and second will be the retail part of the distribution system. So in case of retail part, you can choose the tariff of your choice, and if you are not satisfied, you can change the retail company also. So in that way, you will have better market and services for the customer. Now, next characteristic is the asset optimization. In case of conventional power system network, the asset optimization is very poor. We do not have the data whether the transformers are underloaded or overloaded. We only come to know when the transformers fail. Similarly, the transmission lines, we have very limited information regarding the overloading of the transmission lines and the other assets which are there in the power system network. So because of that, we are not in a position to optimize the power system assets. While in case of a smart grid, we will have data driven predictive asset management where based on the data set we can predict well in advance when the transformer is liable to be maintained. So maintenance period can be defined with the help of data rather than going into regular preventive maintenance. Because if the transformer is regularly being overloaded, that means the transformer needs to be uh, taken out more frequently from the operation for maintenance. So that kind of information is only available when you have the data driven approach for predictive asset management. Now, the next characteristic is self-healing. In the conventional power system network, there is no self-healing because most of the things are driven by the operators. Whenever there is a fault, operators manually uh, take actions to isolate the network and reconnect it. While in case of a smart grid, the requirement is to have the self-healing approach in the power system network. It should have automatic and predictive fault analysis as well as the restoration process. So whenever there is a fault, only the faulty segment will be isolated and the power system will be restored so that the customers are least affected. Now, cyber attack. The conventional power system network is very vulnerable to cyber attack. Why? Because the conventional power system network is not designed considering the cyber security in center. So in that case, because of having lot of legacy protocols which are very vulnerable to cyber attacks, the conventional power system network cannot handle the cyber attacks. While the smart grid is designed in such a way that it is resilient to cyber attacks. Now, disaster management. In case of disaster management, the conventional power system network is very slow and reactive in response to the natural disasters because the process which is being followed in the conventional power system network for the restoration is mostly the manual process, and there is no predictive analysis is being done well in advance to save the power system network. While in case of the smart grid, the restoration will be quick and proactive when there is a disaster. Why this will be quick? Because when there is a likelihood of any disaster, the system will prepare the required assets well in advance, and it will locate all the resources nearer to the disaster area so that the restoration can be done very quickly. Now, the event analysis, the conventional power system has very slow and tedious event analysis process. Lot of things are being done manually because there is no the integration of information technology and operational technology applications. So data is extracted from the fault locators and the fault recorders and the SCADA systems, and then these things are processed manually to find out the likelihood of the fault or the reason of any fault which have happened in the past. While in case of smart grid, data analytics plays a major role because the data integration is of utmost priority in case of a smart grid. So when we have data integration, all the devices will communicate required data almost in real time, and then this information is processed using data analytics applications so that we can save the system from any possible outages or any abnormal activity. Communication. So in case of conventional power system network, the communication is mostly one way. Even in some of the cases, the communication is even not being stabilized. That is being done manually with the help of operators to call the substations and take the details. So the communication is very poor in case of conventional power system network, while in case of a smart grid, the requirement is to have integrated two-way communications. Until unless we have integrated two-way communication, it is very difficult to realize the smart grid concept because the communication will help you to have the data being sent from devices to servers and then from servers to devices more frequently without any problem. The next characteristic is the predictive nature. So the conventional power system network is not having any predictive process and applications deployed. While in case of smart grid, we need to have predictive processes and applications to be deployed because until unless we predict the event well in advance, we cannot save our power system network from any possible collapse or any possible abnormal condition which is happening in the system. Next is the intelligence. We have very limited intelligence in case of conventional power system network because the conventional power system network depends upon operators. So the events are mostly operator driven, and operator takes decision based on any abnormal condition on how to operate. While in case of a smart grid, the system is intelligent to integrate and process the critical information. We have better information sharing among various applications so that we get the output from these applications almost in real time, and system can take decisions automatically based on the analytics data which is being received from various applications. Next is the efficiency. The efficiency in case of conventional power system is very poor, while in case of smart grid, the efficiency of the power system network is of utmost priority. So these are the typical characteristics which separate the conventional power system network from a smart grid. So when we use these characteristics and deploy the solutions considering those characteristics in mind, we can make our power system network a smart grid.